All right, let's fly.
I think we should go. Yep.
Good morning, everyone. I'm Stephen Lazar. I'm with Atmosphere Optics. Atmosphere specializes in fenceline monitoring, so I volunteer to moderate the fenceline monitoring sessions today. There's been a lot of new developments in this track of our industry over the last 4 or 5 years. So this should be pretty interesting group of speakers. We're going to start out with Molex this morning. Barry Kelly and Krishna Palluri.
Oh, you got it.
Perfect. That was challenging.
Nailed it.
Barry has degrees in chemical and environmental engineering. His 35-year career is highlighted by diverse pursuits: engineering officer on an aircraft carrier, serving as a U.S. Navy pilot, commercial airline pilot, and various aspects of environmental health and safety. Barry has a strong focus on innovation, LDAR, and has been a key member of the team that earlier this year gained AMDL approval from the EPA for the use of Molex's groundbreaking leak detection sensor network, which I think we're going to hear a little bit more about in a minute. Krishna Palluri is the Vice President, General Manager of LOT Solutions at Molex. He has over 25 years of software products experience in ECAD, enterprise software, digital media, and IoT software industries in Silicon Valley companies. Prior to Molex, Krishna was Vice President, GM of GE Power Conversion, IoT solutions for power generation, and offshore drilling industries. These IoT software solutions aggregate operations data, provide various analytics for new insights to improve operations efficiency and reduce maintenance costs. Krishna is the author of a book entitled Engineer to Entrepreneur, The First Flight. He holds a BS in electrical engineering and MS in computer science. I'm going to pass out a sign-up sheet. You're going to sign the name in, and we appreciate it. Pass it down the rows. And take it away, Molex.
Thank you. Appreciate it.
Yeah.
That's mine.
Oh, I'm sorry.
Yeah, usually,
I haven't quite woke up yet.
yeah, I usually don't let people steal my
Sorry,
coffee in the morning.
Just get this together here.
Thank you.
Uh-oh. And I didn't turn off my ringer. Sorry.
Good idea.
Sorry.
Well, it's always good to have a nice rock music in the morning.
Yes.
Thank you
My
for
wife
that.
sings a Black Sabbath, and that's her personal ring, so I better send her a text.
So we're here to talk about Fenceline. Just out of curiosity, if you can explain why you're here, it would help a lot because we want to answer your questions as opposed to just sing a song.
People Bradley, a consultant. I'm always curious.
Yeah, like we heard, is doing a great job, mostly because we're getting like from neighbors and such, and so that will primitive fence line monitoring. Future, one of the agencies would make it.
Thank you.
I'd love to see each of us professionally hire. Here to learn more about their product.
For Cook Engineer Solutions.
Chris Carson, agency, area manager,
Very good, APC.
Our manager, Tim Rock, we know him. All right, well, thank you. Any idea how to pronounce this? Take a shot. How do you say this?
mPACT2WO.
Yep, you got it. That's our business unit. We're part of Molex, and Molex is part of Cook Industries, one of the largest private companies, 120 billion plus revenue. So thank you for joining us today. I'm here with my colleague, Barry Kelly. Barry is the expert, and he'll introduce himself a little bit more as we talk. The reason we call it My Fenceline is Clean, How About Yours? Is exactly why the topic you brought up today. It seems like the fence line monitoring has become a different game right now, different complexity, because there are different kinds of, oh wow, we'll pause for a minute. Sorry about that. So So Fenceline has become a different beast over time.
Why don't you just, the people who just walked in, there's a sign-up sheet going around, you sign up, I mean,
Yeah, if you could also write down which company you're from, that would help a lot. Thank you. So, you know, as we talk to customers, we realize that Fenceline has become a kind of a more complicated beast than before. So we're here to share with you not only our technology, but more importantly, some of the use cases. We've had customers who are using our solution. They have to call their neighboring plants and say, hey, you're sending stuff to us. Plants were really confused because they already had sensors there. They didn't know why they couldn't catch it, but these customers of ours, they were able to catch it. There are also situations where community groups monitoring it, you know, beyond the fence line of the water, if there's a water behind them. So any questions you have, let's make it a discussion. And Barry is our expert, and he's going to talk. Okay.
Sure, let me stand up.
Yep.
So a little on current reality. If you're in the refinery sector or work with the refinery sector clinic, then these will be pretty common for you. The refinery sector rule, if you think about what that rule started as, it was a view from the agency that fugitives in refineries were underreported, underpermitted, and overly impacting communities outside. So that rule requires a 2-week passive sampler for benzene. They chose benzene as kind of their surrogate, right? Partly because of its health impacts, partly because of a surrogate for fugitive emissions inside typical refineries. And that setup is you do a 2-week average, right? So you got your sampler out there for 2 weeks. When that's done, you send it to the lab. Lab does the analysis. Then they send that back to you, and that one is really to try to focus on fugitives. It's a delta C, so it really looks at what was the highest concentration of benzene, what was the lowest concentration of benzene during that week, and then it has some action levels that if you're above that, you're required to do some root cause analysis. It has some reporting potential requirements. Some of the challenge with that, though, I mean, obviously, you're doing the root cause to try to figure out what gave you elevated readings sometimes 3, 4, 5 weeks ago by the time you get your results back. Sample tubes, there's definitely some issues there. These are some reasons for not collecting samples or not getting a good sample that EPA has shared. Bear safety is the one I like. Snowplow availability. And then a couple of these, right, where you end up, here's what the sample typically looks like, and you end up with wasp nests in there. So they had one that was, wasp spray contamination, but they sprayed that up in there. Definitely some issues on current reality, where the requirements and how we do that. And then some other things for different approaches. Personal safety, most of the layers of protection are manual right now. There are sensors, there are some connections. ABO inspection is another piece of that. Safe work permits and how you do those. Again, all these are more individualized. And then corrosion under insulation is an issue too, right? That we have to remove that insulation, do the inspection to look for corrosion issues. All those, if you look at them, almost all those have personnel issues, kind of, am I at the right place at the right time? Am I doing a thorough search? Sometimes those are our employees, sometimes they're contractors that are doing those things. Okay.
So if you look at the existing solutions, people use a mix of all kinds of stuff. Passive samplers, of course, are the standard solution that everybody uses. Take 2-week samples, you get back results after 2 weeks, etc. But sometimes people roll in the speciation sensors and try to look at the results with much more accuracy. The problem is a lot of these are piecemeal solutions. They really don't change the equation. They make it a little bit more complicated because of the siloed nature of them. And the data is sometimes too much, sometimes you get too many alarms. The worst in Fenceline monitoring is customers tell us they don't have the situational context. What happened a few weeks ago at that time? They have to rely on their memory to find out what happened. And that's really been the number one concern from a lot of customers. They're under more and more scrutiny, more and more, regulations. If you look at how the regulations are changing, there's quite a bit. And more importantly, communities now, they can fly a drone just outside the fence line and get access to the data. There are non-governmental organizations that are doing this work and providing the data to the community, which had no access to this data before. So it's even more difficult now to deal with some of these growing regulations and community interests. Barry, you want to add anything on the regulation side that things are on the horizon potentially?
Yeah, I think folks that are here are probably well aware of a lot of those changes. You do see whether it's Quad-O with the updates for that, those things where fence line is going to be, it's GDGACs and another one that we're starting to see those where you feel like fence line is going to end up being a requirement in a lot of changes going to that. A lot of that is focused on EJ and communities outside and help impact us.
Yeah, so if you look at the current solutions, they almost look like the old style security guard walking around with a flashlight, doing rounds, and hoping they might find a leak at the same time or catch a thief at the same time, right? So that hope-based approach to fence line monitoring has to change, and this is again for our customers, not based on us. If you look at the existing way the whole insights are allowed, you have to wait multiple weeks to get the return from the sample analysis. And the limitation, big one, is really loss of situational context. And the future, the way we have designed it and how the industry is looking at it, is how do you get immediate real-time feedback of any fence line emissions immediately. Not only that, how do you get a directional sense and the level of leak at that time, right? And if you look at the way people work today, they look at the 2-week average. Can you get that? Because that's something you all use to look at the past and say what happened. All of that information, if you get it real-time access to that one, then you could potentially change the way you work. It is not to replace the passive samplers you have today, because that is the method, compliance method that's dictated by EPA today. But this one augments it and changes the game completely for you. So this is what we call as a current by design compliance. So if you get this right in real time, your 2 weeks passive sampler analysis will likely not show you any surprises. Okay. So it's really simple. The way that works is there are sensors at the fence line pretty much sitting next to the passive samplers you have. That's the easiest way to locate them. So wherever you have a passive sampler, you have a sensor that's powered by solar if necessary. If you have line power, that's great. It can go Wi-Fi, cellular, doesn't matter. The data goes to the cloud. And inside the plant emissions, since you get real-time notifications, you can isolate the leaks and fix them pretty much close to real time. But the more interesting thing is outside the plant emissions. This is where you can actually tell the neighboring plants or show proof that the emissions are not coming from your facility. There could be a truck driving by or parked there, or like you said, ships going by, right? Any of the reasons that are really beyond your control and outside your perimeter. So the advantage of having this kind of real-time insights is you can fix things inside, you can flag things coming from outside. That's why we call it this title that says, My Fenceline is clean, how about yours, right? You have the ability to get to that level of sophistication where when it comes from outside, you can not only prove the others as the emission sources, you could potentially also use the same data-centered analysis and show it to EPA, hey, it's not my problem, it's coming from outside. So when you have data, it's much easier to show the regulatory bodies that it's not your problem. Questions, please.
So, see, with the refinery sector rule, EPA lead pretty heavily on modeling for their site-specific plans. Right now, they're focusing more on monitoring in terms of incorporating some of those data adjustments, calculation, correction factors. They most heavily lean on mobile VGCs. Are you aware of this technology being utilized and approved in an EPA site-specific monitoring plan to account for that data adjustment factor?
Yeah, there is a refinery in Corpus Christi that had approached EPA about using this specifically in a site-specific monitoring plan. The way that they wanted to use it was to account for those near field sources right there. In that case, because this system doesn't speciate, we talked about maybe we can use some ratios, make some of those things to help us figure out how much of the emissions are actually benzene, and that was really the issue there. If you're going to subtract it, you don't want to subtract everything when you're trying to subtract it off the benzene piece. Molex is working right now on a way to incorporate benzene specific data through some GCs or some other things to do that. But that's one we do think that's probably a future piece is SSMD, and then maybe in the future making election.
I've seen the mobile VGCs so far in Texas.
Yeah, the whole idea here is these are parts per billion sensitivity. How quickly can we tell you that things are starting to become bad? Once we tell you that one, either you can use your handhelds or with the integration of benzene speciation sensors, now that we have it, we can also tell you how much it's both. But the key here is really how quickly can we tell you, how early can we tell you that you got a problem coming up before it becomes a real problem.
And each sensor takes a reading per second. So there's a lot of data. One sensor, 34 million data points a year. What we've been doing is co-locating exactly where the R's are.
Any other questions?
I got one.
Yeah, please.
I know EPA is any minute now going to put out a hazardous organic niche proposed rule, and we anticipate Fenceline for a bunch of different pollutants. Are you guys going to comment at all about that and try to get this sort of built in, or?
Yeah, Molex has been commenting on a lot of the rulemaking that's coming out. Quado mentioned that one, the GDGAC. So anywhere where EPA is talking about technology piece, right? Whether it's method 21 monitoring, whether it's a Fenceline system, alternative work practice, right, for the IR camera, any of those, we're adding comments to try to get this type of technology included in that list.
Okay.
So try to kind of get it more on the front end, but then
Right.
also like you're talking about, it's a site-specific plan. We've got an AML going on the LR piece right now to work with them on.
Thank you.
When you ask a question, if you could please introduce yourself so that others
Oh, yeah.
can
I'm there. Formosa.
others can share best practices. Yeah. It's not for us, for others. So this is how the sensors are placed. The sensors are highly sensitive, like I said, parts per billion sensitivity. And these sensors, by the way, are applicable not only for Fenceline monitoring. It's the one solution that addresses LDAR in process units, Fenceline monitoring, tank farms, pipeline terminals, AVO, process safety. One solution that addresses everything, but it configures itself differently for each use case. So it can give you the right kind of alerts at the right sensitivity, etc. So that's the beauty of the sensors we have. And this is the kind of screenshots you get. Now, if I just show you these screenshots, you can, if you Google for, Fenceline monitoring and cones, you'll get 800 of them. The difference here is these are proven in production use real time and proven where My fence line is clean. How about yours? Has been proven. Customers who are using these are able to call the neighboring plants and say, stop it. So, and reliably, right? No false positives. Very reliably, they're able to do it. And it mirrors the way customers work today. You know, they want to know where is the emission coming from. The fat part of the cones is where it's coming in. And how intense is the emission? If it's red, it's high. It's yellow, it's somewhere in the middle, right? So it gives you a very quick idea of what's happening. It also lets you look at the 2-week averages with the slider here. So anything you do today is what is represented here. We call this the operator first approach. We don't get excited about predictive analytics and artificial intelligence. We try to mirror what you do in the mobile apps you have. Ideally, with our applications, you don't have to go to a web application or sit in an office. You carry everything in your pocket on a mobile phone. And when you get an alert, that's the only time you look at it. Otherwise, everything is good. These sensors are designed to be self-expressive. When you install these sensors, you don't have to monitor the sensors. If the sensor has an issue, it'll tell you. Just like it tells you when there is a problem with emission, its own health, it'll tell you, I got a problem, by the way, so I'm not going to be talking to you anymore. Okay? So it's really hands-off, almost like what you have at home with all the systems you have now, the consumer electronics. They'll tell you if something is wrong. If not, you're in good shape. Right? So that's the kind of analytics we provide. And as Barry mentioned, we now have integration with 2 kinds of speciation sensors, benzene speciation sensors. They are overlaid on this one. So you not only have early warning about fence line emissions, you also have benzene speciation information here. Okay? That's now deployed at a couple of our customers and going through the trial periods. Pretty soon we'll be ready to deploy it. And we have 2 vendor sensors who are already integrated in this one. Want to talk about the use case, Barry?
Yeah, so some of the different use cases we see, one we've been talking about RSR fence line, right? Where you've got a regulation that requires you to do something and you want to augment it with this, right? So the system gives you real-time data. You're able to look at, if you do get an elevated reading, right, that comes back in the past, you can go back and look and say, okay, where were the peaks? What was going on between 12:05 and 12:30 on this day? Talk to ops and find out what, what kind of activities were going on, what condition your plant was in. So that's one set of folks. Another are folks that are in kind of a congested area. We have a lot of, in the refinery specifically, that we have a lot of industry neighbors all around. That's another place where it's very, very useful. The ones we've been using at Corpus, those businesses there have a great relationship, and so it's not about a blame thing, but our site's actually able to say, hey, we're getting a hit, it's coming from this direction, it looks like it's your tank over here, you might want to go check that out, right? So that kind of partnership has been very helpful too. And then the other piece is folks that don't really have any requirement for it, but do have some sensitive off-site receptors. We have one facility that we put some fence line monitors in that has a school that's not far outside the fence line. We've got another that has an inter-river ball field. And so again, their idea is early morning, getting information quicker to be able to make changes when they need those. One of the key pieces on this, though, is I mentioned that every reading is, every sensor takes a reading every second. We also install with it a wind sensor. So we're taking a wind, speed, and direction every second also. And by pairing those, that's what helps us be able to kind of pinpoint and say, hey, something's going on over here. It's coming inside, it's coming outside for those.
How many of you deal with this kind of a situation where you have neighboring plants that could be a problem?
You don't have to give any names of who they are.
Another one that Barry was talking about. We have customers who have elementary schools outside, baseball fields outside,
Larry, you want to elaborate?
Yeah, just what I would say here, I mean, we've talked a little bit about these already. This is a pretty good shot of what the sensor, it's actually in this case right here. And the sensor is on the bottom. It's very small. If there is an issue in sensor maintenance, Molex has designed those almost like a quick disconnect on air hose. You can just pop one off, pop a replacement on, pump test it, and you're back up and running. These on the fence line, we typically use solar for them because most folks don't have line power out there. And then for the upload of all that data, it goes on the cellular.
So it's pretty much you roll it there and it's ready to go right away.
You guys say
5 years.
after 5 years it will be in,
Sorry?
after 5 years it will happen.
Yeah, we haven't been around for 5 years yet
Oh.
actively, but the idea is to put it in what we call as cold storage in the cloud, but we can always get it out. Yeah.
And I mean, for the fence line monitoring, you know, there's a part of the air permit that requires generally refineries. Their equipment meet equipment specified in the regulations. That monitoring.
Yeah, so it depends on the reg. The one we were talking about initially before we came in was for refineries specifically, the RSR. And that one is pretty prescriptive, right? That it's a passive 2-week. Okay. Now, one thing that rule does do is it sets up, you can do a SSMP, a site-specific plan, and there's a approval process for that, and alternatives. So that rule at least envisioned the ability to use other things. And just for different rules, right, like I mentioned, GD Act right now, that's, you know, minor sources, but that's the gas distribution. That's one that's going to probably have a fence line requirement in it, or at least a recommendation or an option with that exact detail. Yes, sir.
Yes, can you talk a little bit about the technology of the actual sensors used, manufacturers and detection?
No, we cannot talk about, it's our sensor. It's our sensor.
Okay,
A lot of times people ask us, do you sell sensors? No. Do you sell software? No. What do you sell? We sell transformation. We change the way you work. If you're looking at the passive sampling tubes before and waiting for 3 weeks, now you look at your phone when you get an alert. That's a transformation.
The sensors themselves is proprietary.
So is it similar to a gas sensor and your 4 gas monitors, they just pop out and pop it out?
Yeah, but it's not a personnel carrying one.
I know,
Yeah.
but it's
Yeah.
similar to just pop it out.
Yeah, and one of the cool things, and we didn't talk really about the development, but both companies, Lincoln Hills Resources, some of the other chemical and fertilizer companies or businesses work with Molex. We're all under the same parent company, so we're able to really share data, bring them in, tell them what we need, and those are the kind of things, right? We're like, okay, I don't want to just now be in the sensor maintenance business, right? So if there is an issue, it sends a note, says, you know, I'm flatlined or I'm not getting power, and it can make it really simple. Just place one or pump test.
So the pump test equipment, take it out to that.
We actually maintain it all for you.
Yeah, so one of the things about this system is it's parts per billion, right? So it's very sensitive. But because you're really looking at every second what are all the sensors doing, right? Oh, this one went up, this one went down, this one, it's doing this next second. So all that's being computed in the cloud, in the end, if it's measuring 5 parts per billion, it's really 6 parts per billion out there. You don't really care, right? And so that's been the email that we're doing for Eldar. EPA's agreed just to let us bump test quarter, right? So think about most of your monitoring systems where you're doing daily cows, you're doing a lot more frequency. Again, in this case, it's just a response, right? So we the same thing as you've probably seen before. We just walk up, we got the mobile software. We say, hey, I'm going to do a bump test. You stick the suction cup under there. You open the valve. We're using isobutylene for the standard, and if it gives you a response, response in 30 seconds, it's at least half the standard,
Yeah.
and you're good.
And that's also supported on the mobile app.
Yeah.
Everything is simple. One of the things I always tell a lot of people are curious. What's the sensor technology? What's the software technology? Where is the cloud, right? When you use iPhone, do you care which processor it uses, which Wi-Fi chip it uses? It's a user experience. And we really wanted to focus on that part to make sure boots on the ground, not chief digital officers, boots on the ground, can pick it up and say, I know what this is because this is what I do. We spent a lot of time trying to get that right, working with the Coke companies. Believe me, external customers are easy to work with. Coke companies are very demanding. So, yeah.
Can you comment more specifically on the actual detection limits or just PPV as well?
Well,
Yeah, so what I think is interesting here in the application, so it is PPP level. So, I mean, it's 1, 2, 3, very, very small. In the fence line application, you really are measuring what's going across there. So it's a pretty good corollary. When we look at the same kind of system that we're using in the LDAR space, there it's a little bit harder because it depends on how far away the sensor is from the actual leak. So those more have a range. Worked with EPA, ORD to kind of develop what we think the top end of the range of the bottom, some of those kinds of things. That one's a little more, it's not your traditional, hey, here's my min detection limit.
Yeah, one of the key things we have done is we don't like this idea of a sensor at one spot trying to figure out what's happening. We have this approach called system versus spot. So all our sensors, when they pick up readings based on the wind, the way it's blowing all around, we take this as a network, and then using machine learning, we try to figure out which one has the best possibility to tell you the direction and the intensity of the emissions. So that's an important one because most sensors that are in the marketplace, you put them there and say you're by yourself, but that's not going to give you a good answer, right? So that's why we made it a system that can figure out, even with the wind, we call the wind our friend. So that's the key.
Nothing to worry about the cost for the investment.
If you're willing to buy it, please come to 401 and we'll talk. Sorry, you had a question.
Sure. Steve Bradley with Solar Consult. So in terms of the notifications and user-friendly and whatnot, it seems to, I'm curious, do you have different settings or different elements so that you're in a defensive mode, picking up something coming to your site, you're going to get one RFK is going to say it's cars going by or it's the time that's right in our fence line, or another set of notifications for something that's coming inside your fence. Opposite way, do you have a sort of notification in terms of directions, or is it sort of a pull up at the end of the day and see what's...
No, you don't need to pull it at the end of the day. It's real time on your phone.
Yeah.
When you pick it up, it shows you the direction right away,
Yeah.
which side it's coming from. We try to minimize the configurability of a system because if you look at, again, iPhone, they give you the phone and you get going, right? So we try to minimize this software, can I sit here with a big dashboard and configure it?
Like the same set at your at locations, whether it's on site or off site, and crosses the people up and see where it's going.
Yeah, that's one that we didn't really think about doing. I mean, partly because we feel like we need to react either way, right? Whether it's an internal or whether it's something coming off site. So that's what we've done. It is set up that you can select what kind of information you want to get, right? So like if there's an issue, a mechanical issue for a little bit, I probably don't care about that, but I'm more, on the environmental side, more interested in large readings and how those impact. So it is set up that way. One thing Molex did too, they really set it up more on a distribution list on how you get that information so that I don't have to call them to go, hey, this person's role changed, we hired this person, this person's no longer there. We can, as the company and site, we control the access between what and how on this system and on the other, the LD.
guards, you know, and your dock monitor, you can make some notes saying somebody's out there, here's a ship registration or something.
Yeah.
Yeah, believe it or not, we actually, I don't know, I don't think we had that case study here, but we actually had one, Corpus Christi where at the hit, they started looking and it was a barge they didn't know about, right? So it was like, one went in and then another, there was like, let's just sneak another one in behind them. So it, you know, not just from environmental, but operations, a lot of information that the sites really embracing.
By the way, all of that information, it's captured by you, by the people on the ground. In the mobile app, there is a response workflow where you can take pictures, you can put notes, and it goes to the cloud and gets centralized, and you can access it from anywhere again. So the whole detection, isolation, and response is all captured within the mobile app. One shot. And the mobile app, the response workflows have different rigor based on the use case. For Fenceline, for LDAR, for tank farms, et cetera, the response workflows are different. And they mirror everything that you do today in your operations. Okay? That's pretty much it. Any other questions, comments? And we are in suite 401. If you want detailed demos, pricing, anything, you know, we'll be happy to talk.
Mike Miller with TCQ. Other than the sensitive receptors, which you talked about in your slide, in terms of strategic placement for the refineries that are subject to the Fenceline monitoring provisions, have those sensors been deployed kind of spaced in between the method 325A samplers, or are they co-located, or what's been the strategy in terms of sensor placement for refineries that are already monitoring?
Yeah, we've been basically co-locating, right, with the sensors so that we are really getting the true comparison, right? So we're getting real data, we're able to compare what those 2-week passive samplers are looking like. So that's what we've been doing on the Fenceline specifically. On the in-plant applications, which are really similar technology, just like Chris was saying, maybe a little workflow on how you address them. Those that are on the in-plant, on the process units, and those we put, we're a little more thoughtful on what is the thing, what's the problem we're trying to solve. Is this just an LDAR replacement? And we focus on where LDAR components, is it more of a safety where, okay, this is a high pressure operation here, we want to have more sensors around there. So in those cases, we do kind of design the layout for what's the issue.
So we have a software to which we feed in all these requirements, and it spits out the placement that's optimized for coverage, detection, and accuracy. Any other questions, comments? Well, thank you all.
Thank you very much, Barry and Stephen. Really appreciate your presentation. That's pretty good. Rough start.
Thank you. Thank you.
So I haven't even seen where the presentations are.
Here on the, this one, I'm going to take it out.
Oh,
I forgot how
you
to-
brought your own?
Yeah.
Okay. Do they have them loaded somewhere?
No.
Oh, I don't. It was supposed to be loaded.
Supposed to be, yeah.
Yeah, no.
I brought mine too, yeah.
Oh, safe shape. Nice to see you.
I'm sorry I don't have a name tag, but I don't exist according to them. They gave it to me and it was blank. It's like, well, okay. They're having some kind of issue with the printers,
Well, I gotta
but,
hold my breath before I take it.
Do your introduction.
It's quite a mouthful.
oh my lord, don't.
What should I say about it? What do you want me to say? How do you want me to introduce you?
Just that. Just the
The
top.
first paragraph, okay.
Oh, I know. You wrote that. Did you write
I'm not-
Did you write this? My intro thing?
No, it's just almost as well.
No, just the first paragraph is good,
Is this a Montrose presentation?
Yes.
Doesn't say. Okay. Yeah.
Have you posted presentation of before?
Yeah, but it's been
modified. It'll probably work better off the jump drive if it's, I just loaded it in this morning, but I'm not sure if it got out.
I'm sorry, I missed that. Well, I hope what you heard. It sounded better. Background music. That was fun. I think a lot of people have contextual awareness of people, so we can see somebody with the context.
But I, you know, I mean, getting kind of over on
Steve,
I know you're gonna talk to myself.
you've never seen me play in Denver, you come all the way out here, and you still don't.
I'm in the
You're in the same room.
Next time.
Oh, perfect. Sweet. All right. I promise I won't talk very long, so.
I'll introduce you in a minute here.
Nobody wants to give me a shot, but, you know, don't worry.
How you doing, Steve? See that. Yeah, you made it back to Texas. There's life outside of Colorado. Yeah. Oh,